I'd like to introduce Michael Newman. Michael is a color management specialist and consultant. He lives in Olympia, but he works in Seattle and Portland. So he's here and all over the Pacific Northwest.
Yeah, pretty much everywhere.
Michael's been doing this for
10 years, yeah.
And over the last couple of years, he's specialized, he's taken a special interest in digital cameras. I don't want to say he's specialized in that because he does a lot of other things, but he's taken a special interest in digital cameras, and that's why we're here tonight, and that's why we've asked him to tell us all about what he's learned and help us understand it better. And I guess that's all I have to say.
I'll get the slideshow started here, and hopefully everything... It's recording already. All right, good deal. All right, so this is a little bit about me. I do color management, display calibration, printers, scanners, projectors, digital cameras. And one thing I'm going to talk a lot about tonight is light. It has to do with what we're doing here. We're capturing light with cameras. So such a big part of that is about light. One thing I wanted to add here was that I'm doing, basically consulting on lighting specific to digital imaging. What kinds of light, how to deal with them, how to work with them, what does what. So something I wanted to add. I think with that we can get... Yeah, well, this is why I'm here. This 10 seconds and now it's over. All right. So key things we're going to cover in the first half, and we're going to have a break. And I have to warn you, this first half I'm going to go very, very quickly. I'm going to cover an amazing amount of very technical subjects. I don't expect you to gather all of it. Okay, that's my preface here. I want you to get a gist, okay? Because a lot of you have worked with some of this before, maybe seen it, maybe have not seen it at all. So I want to kind of get us all to the same point. We're going to talk about light, very first, and color, and how color is light. The hardware of actually capturing that, everything from your digital camera, your actual eyes and film, and then the software processing what we captured. Call it software because our brains are software, at least in my presentation tonight. And then the tools for dealing with that, primarily white balance, camera settings, the workflow on your computer, because that's going to be a big piece of it. And then the tools for doing camera calibration and profiling, which is really kind of focused tonight. But I really want to, if you're not specifically talking about camera calibration and profiling, it's color for cameras. And then selecting a workflow, what works, why, what the advantages are, what options you have at each step. So light is electromagnetic energy. It comes in different frequencies. The key thing I want you to pick up there. Infrared off one end, ultraviolet on the other, and we have a very small area that we can actually see. This kind of represents that specific frequencies that we can see. So like, for example, yellow on the right-hand side here. There's a lot of energy in these higher frequencies. Blue is going to be more energy in the lower frequencies. Red, just the high frequencies. And purple is a little bit unusual because it's got some low energy and some high energy. Again, I don't expect you to pick up all of this, but just keep in mind frequencies of there's lots of different kinds of light. They're at different frequencies. It makes a big difference if you kind of get some grasp of what's going on here. If you look at those frequencies and you spread it out, you get this nice little chart. These, again, talking about specific frequencies in the, how many oscillations we're getting in that wavelength of light. So we see with rods and cones in our eyes, we've got a lot of rods. They only sense brightness. We've got a few cones, more towards the outside edges. There's different kinds of them, and they pick up on different frequencies, each little cone. So really they kind of come down to like red, green, and blue sensors. It doesn't actually work that way, but that's the general idea. Nobody really talks about film too much anymore, but a lot of people spent a lot of time really getting to know how color worked when they were using film. And I didn't, but hey. So when you're talking about film, light comes through the film, the grain gets exposed, and it sort of activates a specific layer as it travels through. So those lower frequencies get absorbed first, and the higher frequencies that are vibrating much faster can go deeper into the film. That's the whole idea of the way it worked. Positive and negative had different sensitivity. They bleached out the pigment and just left the color behind. I'm not really an expert on that subject, but in any case, it makes a difference to kind of understand that there's huge differences between where we're at now and where we were. Digital works in a different way because we don't have layers. There actually are some, but most cameras don't have layers. And what happens is we filter everything out but red or green or blue, and that comes down and hits a little sensor, and it gets transported off to a processing thing that stores the signal and digitizes it. Too much of this you don't need to understand, except for the fact we've got filters in there that block everything but a specific color. When we're talking about film versus the human eye, this explains some of the differences. Here's the frequencies that those little cones picked up at. So this one primarily picked up red, this one more green, and this one more blue. And film does the same idea, but they have different frequency ranges and big gaps in the middle. And they pick up different amounts at each frequency. So our eyes are much more sensitive to blue than this, I believe, is negative film here. Kodachrome 25, real popular film. I don't have a nice pretty graph of it overlaid with the human eye, but you can see that it has a very different shape to it than this other film did, which is why you picked one film over the other. This film really works good for color, and why your green fabrics sometimes came out gray, because they fell into a specific area where they got measured as being gray, because there wasn't a sensor in the film. Well, it wasn't receptive to that frequency of energy. Like I said, a little technical, but it makes, if you get a vague idea of what's going on with these frequencies. The actual chip that's sensing, the silicone wafer that's underneath that filter, actually picks up a massive amount of energy. So this is way off the visible spectrum, up into ultraviolet energy here, and all the way down into infrared, if I'm not mixing those up. And it means this is why you can have cameras that see in the dark, because they can put a specific filter that cuts out all that, and all it picks up is this energy. Or you can have cameras that are heat sensitive and block everything but the heat spectrums. It also means that they're very, very different than at their fundamental nature of sensing light. So what we do is we put these filters on top of them. This one, we've got a nice graph here of what the blue filter lets through. Okay, the green filter and the red filter. And this is very much like what our eyes kind of do, but they've got some weird little bumps in them, and the blue drops and then goes back up again. And like I said, a key thing is they're not at the exact same points. This lighter graph here, the sort of purple now and cyan kind of color, these three represent the human eye, and these darker ones represent a camera, specifically a Canon 10D and a Nikon D70. I've had a very hard time finding this information. So these are the cameras somebody went out and measured, an astronomer, if I remember right. So I don't know how exactly accurate this is, but it gives you an idea that we see red way over here, and the camera sees red, at a different frequency and a different sensitivity. Green's much closer, but still some differences. Blue, again, very different. It's a much higher frequency than our eyes see at. So once we have these signals coming in, a whole new set of things happen. I'm calling that software for this section. We take that signal coming in for our eyes and we apply perception to it. Okay? What that means is that we balance it out to get what we want out of it. We interpret it so that everybody sees it differently. And heck, you could have a weird mood and be seeing light differently than you saw it the other day. If you're tired, for example, if you've ever done a lot of color correction, you'll find that you actually see things differently depending on how you feel that day. Once you're actually trying to match products and you have quantifiable things, you all of a sudden will really notice some